Hi guys, this is part 3 of lecture number 2, and then we'll be speaking about the network of networks. In other words, we speaking about the internet. So you can see the internet as an international network of networks. So you have to know some definitions. We spoke about that earlier. Like there's one that will come very often in this lecture, ISP or Internet Service Provider. So we have multiple sort of internet service providers. We have the access internet service provider. Those are basically giving you access to internet. Like we won't be speaking about that too much. We have the regional internet service provider. Those are bigger ones. They basically link you within the same region in an area. You have your enterprise internet service provider, and you have the commercial ones. So as you know, internet is used for multiple reasons, and internet is becoming faster and faster today. Why? We'll be speaking about that in the next slides. Now let's assume that in our network, our internet, we were just connected from literally from one point. We're like point A here, speaks to this point, speaks to that one, speaks to that one. That will be very inefficient, as you can see, because if I live somewhere here on one side of the globe and I want to speak to someone here on the other side of the globe, it will be very, very, very difficult. Imagine first of all the distance between Johannesburg and Durban. Now you have to imagine the distance between Vancouver and Tokyo. That will be a mess. So as you can see, if we have n users, right, and then if we have n users, we have obviously n minus 1 links or edges, right? How many connections do we have? We have n times n minus 1 connections. What does that mean? In terms of complexity, if we get rid of this negative 1, then the complexity of the amount of connections here, it's like the time taken from one point to another one for everyone will be of n squared. It's like it will be of complexity n squared, and we know it's very inefficient, right? So that will be bad. If everyone in the world wants to connect, we'll be having this number of connections, which is not good. Now what we do, we can say, okay, cool, we can have someone like an internet service provider with switches in here that can help us to connect, right? So it will be slightly easier, right? It will be slightly easier in the sense that we do not connect to each other anymore, but then we're sending our packets to some switches, and the switches will be then there to forward the packets to the concerned persons or computer network device. The problem is, remember when we were talking about packet switching, we have an inbound queue or buffer, and then we have an outbound buffer. Not all the links have the same size, or not all the links have the same transfer rate. There will be a trouble in the inbound queue because you'll be full, and then we'll be losing packets. So what we can do is to break down the global internet service provider into different internet service providers, right? That will be nice to do that. The problem is, as you can see, these guys are separated from these guys, are separated from these guys. This is one thing, and that creates competition, because if this internet service provider is not performing good, then these guys will say, okay, cool, we're connecting to this internet service provider because it's faster. And if it's faster, and then a third of the world is connected to one internet service provider going to join another third of the world, then we have 2/3 of the world connected to one internet service provider. That will create trouble. It will be as slow as the global internet service provider. So what we do, we now have what we call, at the end of the day, we have the internet exchange points. It balances out, right? You have these guys, right, connected to this internet service provider. Same for the other people. And the internet exchange point is basically there to say, okay, fine, you know what? From all the internet service providers happening in an area, I will be collecting all your requests and then propagating it to the other side of the world. There won't be any fights, there won't be any competition. There will be just one guy that will play the messenger, right? But then, now let's assume something. Let's assume that this particular user wants to speak to this particular user. It means that he or she has to send his request down to the internet exchange point, and then the internet exchange point will come and send it to this user. Technically it's fine, this is one problem solved, but they're very close. So what can happen, we can have what we call a peering link, right? A peering link is a mutual agreement between two internet service providers so that they can bypass the internet exchange point by that agreement, reducing transfer costs and then helping the customers. So it will be just a matter of coming this side and going back to the user. For your information, in South Africa the we have the Johannesburg Internet Exchange Point, and then we have the Cape Town Internet Exchange Point. You can go and check them, and they basically very used. They are the internet service point we use when we want to speak to the internet. You can Google that. It's a very nice reading. Cool, but then we still have a problem. These internet service providers with the internet exchange point, they're big, right? It's like, let's just take this cat right here. Okay, here we're in Braamfontein, here we are in Melville, okay, we're still in Johannesburg, here we are, let's say, in Durban, in the KwaZulu-Natal, and we have some of the people here in somewhere in the northwest. Let's assume that. I forgot the name of that town in the northwest. Thought I forgot, sorry. Now, we have this big one. It will be pretty inefficient to say that if someone from Durban wants to speak to another one in Durban, needs to go through these links and all those things. And that will be just bad, because we want the people from the KwaZulu-Natal to communicate as fast as they can. They need to have an internet service provider that's closer to them. That's the reason why there is a regional internet service provider as well, right? So in this case, we also have a regional service provider that will make sure that if I want to speak to someone in Gauteng, for example, then it will be quicker for me, instead of sending my data over the internet and then it comes back to Gauteng where I needed my message to be broadcasted. That will be good, right? And that's very great. That's another very big improvement. But then now we now have a bigger one. Our like, we have our internet service provider here, the big one. We have the regional internet service provider. We're now very well connected. But then what if we have someone in Vancouver, Canada, and then we have someone in Tokyo, Japan, right? Now, the person in Tokyo wants to access a server in Vancouver, right? Vancouver. The server is here. And imagine that someone is in Tokyo wants to access that particular server. So in Canada, the website the ends by .ca. So we want to access a .ca website from Tokyo. We want to access a .ca website from Johannesburg. We want to access that server from maybe Berlin, in Germany, right? We want to access that particular, or let's even not even the CA. An example that's closer to you. You have a friend that's having WhatsApp on the other side, and then you want to communicate with that person that has WhatsApp. What happens if you send your message across from Tokyo to Vancouver using the WhatsApp server and using the current infrastructure that you have in front of you? Then you'll have to cross all the switches, you'll have to cross all the internet exchange points, you'll have to cross some more switches, and then you'll have to cross some regional ISP, and then you have to go there. Imagine that type of delays when you have to send a message to someone to do something in the next second when the message takes that long to get there. So what happens, they are what we call content delivery networks. Content delivery networks or content provider network. They just mean the same. A content provider network, it's basically a server, a physical network, a physical server that sits where the customer is, and that kind of caches or replicates the content of a remote server. So let's take our example. We have WhatsApp. WhatsApp, it's somewhere here in Vancouver. This is our friend from Vancouver, and we have our friend in Tokyo, and then we have our friend in Johannesburg, and we have our friends in Berlin. And they're all friends, they're using the group chat from WhatsApp. How cool is that? But then now they need to speak to each other, right? So what the content delivery network is, or content provider network, for example, Google, it's a very big one. They say, okay, cool. Instead of you guys speaking directly to the server, or speaking directly to send it directly the messages to your friend in Vancouver, what we do, we basically have our servers here next to you, where you basically have a replication of what's going on here, and then you just speak to that. You speak to this and you speak to that. This is a replication of the server. But I know some students might ask me, what if the server changes? Yes, that will be an issue, but it's not a very bad one. So the server will basically broadcast the change here in such a way that you always have the latest change. Nice thing is, you don't have to always send the, let me just clear the screen, it's becoming messy now. You don't have, we still have our Tokyo guy here, and then we have our Vancouver guy here. You don't have to send multiple requests to Vancouver all the time, because you have your physical server sitting here in Tokyo. Then you just making your request to Tokyo. Your computer is making the request in Tokyo, but then you are thinking that the request is going to Canada, and then it goes quicker that way. And there is the structure of the internet. In another view, the internet works this way. You have your internet access providers. Those are literally the means that allow you to connect to what we call a regional service provider. So they send your request up here, and after the regional service provider, like AfriHost for instance, then they all connect to this guy, to an internet exchange point. Instance, we have the Johannesburg Internet Exchange Point. Please go and Google that. It's a very nice topic. And then the Internet Exchange Point now connect to the Tier 1 ISP. Those are the bigger ones in Internet or information delivery. As you know, the Internet, before being wireless and all of these things that we know about that, those are physical cables that run under, like underwaters, like it's literally running on the sea. Those are very, very big and strong cables that connects continents, and then they are maintained by big, big companies like AT&T in the United States. They are the one maintaining those cables that will basically come to South Africa, for instance, and then it goes into the whole power plant. Like your data is going through those cables and it's being dispatched everywhere. But then instead of using those cables, you can also use the content delivery from Google that will basically make your message travel quicker. But at some point they also sometimes rely on the tier 1 ISP, because the content delivery network is just a replica of a server that's sitting somewhere else that we don't want to touch that often. We don't want our signal to travel that far for us to have a result. That's the thing. Now, this is the tier 1 ISP representation in the United States, or in America in general, because now there's Canada on top there. So we have a similar map for the South African or the Southern Africa scenario, where we have this type of physical cables that basically live from one side of Africa to another side of Africa and another side of Africa. So we won't spend too much time on the American map because it's not very easy to relate to. But then I'll have a practical, like a different video, like a practical video that shows you each and every little components that you need to know about networking. It's a very, very, very interesting topic. We only live about networking. That's how we communicate with our friends and family. So it would be a nice thing to show and to prove that this is a great skill to have. And this is the end of this section. The next one will be mostly speaking about the performance, loss, delay, and throughput. Thank you.